Let's talk about the composition of functions. So if I have the composition of functions, I'm going to use this notation. It's f and then this circle. It's not a filled in dot. It's not the same as multiplication, but it's an open circle. F circle g, that means find f of whatever the g of x value is. So it's kind of like doing the laundry. You're going to take something, the dirty clothes, and put it into one machine and the washer, and it's going to change it, right? It's not dirty anymore, but now it's wet. And then you take that result and you put it in the next machine and you come up with the final result, dry, clean clothes. So in this case, when I see f of g of x, that means I take my x and I put it into the g formula, work it out, get an answer, and then I take that answer and put it into f's formula. You can also think about it like an assembly line. So again, this notation is read f of g of x. Some countries, some people will say f circle g of x. And if you want to be very formal, you can say f composed with g of x. I think if we do an example or two, that'll help you wrap your mind around it. So if I have f of x is 5x plus 2 and g of x is x squared minus 3, and I'm told to find first f of g of 2. So I'm going to read that, f of g of 2. What that means is f of whatever that g of 2 value is. So we're going to take the 2 and first go into g, get our answer, and then put that answer into f. So how do I find g of 2? Well, I take that 2 and I plug it in up here, which is where I got the 2 squared minus 3 times 2. I simplify that, it becomes a negative 2. Now I take that answer and I plug it into f's formula. I don't go back to the original x I was given. I keep moving forward with my new result. So in this case, my final answer would be negative 8. Now if I reverse this and instead of f of g of 2, I say I want to find g of f of 2. Well, in that case, what I'm being asked to find is g of whatever the f of 2 value is. So g of, this time we put the 2 into the f formula first. That simplifies to a 12. Now I've got g of 12, and I'm going to take the 12 and put it into g's formula, and I get 108. So you can see here that the order of composition matters a lot. You get radically different answers if you put, depending on what order you put it in. If we look at the general case here, we can see why that is. If I have f of g of x, that means I need to figure out what g of x is. Well, that was given to me. It was the x squared minus 3x formula, and I want f of that. So that means I take all of this stuff and I put it right here in place of the x in the f formula. So that's where that 5 times the quantity of x squared minus 3x plus 2 comes from. Simplify as much as we can. Again, if we reverse it, we're going to get a different answer. So if I have g of f of x, then I want g of whatever f of x is, and that is 5x plus 2. Now I take this and I put it back up into g's formula. So that was whatever x is being squared, so it's my whole quantity being squared, minus 3 times whatever my x is, so 3 times the quantity. Now don't forget, when you have a quantity, a binomial squared, that means you're multiplying it by itself and you're going to have to FOIL. So that's where these first 3 values come from. And then we distribute the negative 3 and finally combine our like terms. Now, I can also do it with other types of functions. So if you want to give it a try yourself, just pause this and see if you can come up with the answers to these 3. F of g of 5. Remember, 5 goes into g first. F of g of negative 3, and g of f of negative 16. Okay, if you paused it, you can check your answers now. So what I have here is f of g of 5 means I'm going to keep f hanging around for a minute. I'm going to go figure out what g of 5 is, so I plug it in over here in the g formula, and I get f of 7, then I plug that into f's formula, square root of 7, it's best I can do. All right, the next one though says f of g of negative 3, so I take the negative 3 and put it into g, basically the same, but this time we run into a problem because at the end I get the square root of a negative number, which is not a real number. That tells me that -3, although it gives me an answer for g, is not going to be in the domain of the composite function. We'll talk about domain for composite functions in another video. But just know you may run into that, so be careful. Then I have g of f of 16. So this time it's reversed. It's g of f of 16. So I want to find g of the f of 16, whatever that answer is. So f is the square root function. We'll figure out square root of 16 is 4. Then we take that 4 and plug it into g's formula. All right, and then we can, of course, do this for the general case as well. So if it says f of g of x, well, g of x is the 2x minus 3, and then I plug that into the square root. So what I did is I took the g formula and plugged it in place of the x there, and that's it. Let me know if you have any questions.